let us see what is apparent depth, and let us derive an equation for apparent depth for near normal incidence. So here there is a tank filled with water and a light ray coming from this object. After refraction, it is passing along this direction. Here light is traveling from water to air. So it is bent away from the normal and it appears to come from this point. So this is the apparent depth. So this is the real depth. This is normal, near normal incidence. So the light ray after the refraction is bent away from the normal. Now this is the angle of incidence and this is the angle of refraction. So light appears to come from this point. So this is the apparent depth. So this is the real depth. A tank filled with water. Then the bottom appears to be raised. So this is what is apparent depth. Now let us see how to get a equation for apparent depth for near normal incidence. Now let us derive an equation for apparent depth. Here light is entering from water to air. So here refractive index is N1. For this refractive index is N2. Here this medium is air. Air refractive index is 1. So N2 is 1. So here light is starting from O and here it is undergoing refraction. So this is the angle of incidence and this is the angle of refraction. Then as per Snell's law, sin I by sin R is equal to N2 by N1. Then in the product form you can write like this after rearranging: N1 sin I is equal to N2 sin R. Here angle of incidence and angle of refraction are small. So in that case sin I is approximately equal to tan I. Similarly sin R is approximately equal to tan R. Sin R is approximately equal to tan R. So instead of the sin I, we can write tan I. So N1 tan I is equal to N2 tan R. Instead of sin R, we can write tan R. Now in this triangle, tan I is dB by OD, tan I. So this is angle of incidence and this is also angle of incidence. These two lines are parallel, so alternate angles are equal. So this I, this is also I. So tan I is opposite side by adjacent side. So dB by OD. N2 tan R in this triangle. In this triangle tan R is opposite side dB by IT. This dB will get cancelled. So N1 by OD. OD is the real depth. So instead of OD, you can write D, real depth. N2 by ID. ID is the apparent depth. So instead of ID, we can write D dash. So our aim is to find apparent depth. So D dash. So after rearranging, you will get an expression for D dash. So D dash is N2 by N1 D. So D dash is the apparent depth. D is the real depth. Now here light is entering from water to air. So refractive index of air is 1. So N2, instead of N2 we can write 1. Then instead of N1 we can write N. So we are getting expression for D dash. D dash is 1 by N D. So this is the apparent depth. Then the bottom appears to be raised. Then this can be d minus d dash. D, you subtract d dash, so d minus d dash is d minus, instead of d dash you can write 1 by n d. So this d can be taken outside, then 1 minus 1 by n. So the bottom appears to be raised by this value d into 1 minus 1 by n.